the stars of the day, dear participants, and my dear students. RECERCA 2020 is indeed the rarest of rare moments. It is a national online project presentation competition organized by Research Committee, St. Joseph's College for Women, in association with Kerala Shastra Sahitya Parishad. Today, we are honored to have two eminent personalities as the panel of judges, Dr. M. Ragam, Assistant Professor at Research Center of Physics, Fatima College, Madurai, and Dr. J. Emima, Assistant Professor, Holy Cross College, Tiruchirappalli, Tamil Nadu. I take this opportunity to thank Dr. M. Ragam and Dr. Emima for joining us amidst of their busy schedule. We, the staff and students of Physics Department, would like to extend a very warm welcome to both of you.
Thank you, ma'am.
I'd like to extend a hearty welcome to our dear principal, who is always a strong pillar of support in all our endeavors. I also take this opportunity to welcome Dr. Anju Amelia and Bhagyadi, coordinating and conducting such a meaningful event. Success comes only to those who believe in themselves and are prepared to win. Dear participants, we are proud of taking part in national project. All the best, and may you all do well and come out with flying colors. Once more, I'd like to take this opportunity to congratulate each and every member of the research committee headed by Dr. Bhagya for their teamwork to make this event a grand success. Also, Dr. Sister Morris Marley for coordinating today's competitions in the area of physics. Once more, welcoming each and everyone. Thank you.
Thank you, ma'am.
Over to Sister Marley. She'll be giving a detailed introduction of our eminent guest of the day. Thank you.
Thank you, Dr. Rosalina. And now, I would like to take this opportunity to introduce our subject experts, Dr. Ragam and Dr. Emima Jaronsia, for this National Online Student Research Project Presentation Competition to all of you. Dr. Ragam, who is an Assistant Professor at the Research Center of Physics, Fatima College, Madurai, has 15 years of teaching experience. She has completed her PhD degree from Madurai Kamaraj University, and she has been active in the field of research and academics. So much so, she has published 10 research papers in reputed international journals and presented many papers at the national and international conferences. She has also received one Best Paper Award and the DST Women Scientist Fellow. It is our great pleasure to have Dr. Ragam as one of our subject experts. On behalf of the management and of the research committee, once again I welcome you, dear ma'am.
Thank you so much, sister.
Next, I would like to introduce Dr. Emima Jaronsia, an assistant professor of the Department of Physics, Holy Cross College, Tiruchirappalli. She has completed her MPhil and PhD degrees from Loyola College, Chennai. For her MPhil, she bagged the first rank and received a gold medal. Dr. Emima has published 13 research papers in reputed international journals, 10 publications in conference proceedings, and her area of specialization is nanoscience and nanotechnology for biomedical applications. She has also attended many national and international conferences and has won twice the Best Paper Award. And it is real pleasure for us to have Dr. Emima as one of our subject experts today.
Thank you, sister.
So on behalf on the management and of the research committee, I extend to you a warm welcome. Welcome you, ma'am.
Thank you, sister. Thank you, sister.
So now, shall we begin our presentations?
Sure, sister.
First, we shall begin with the PG presentations. So, PYPG 001, Aishwarya PS.
Yes, ma'am.
Are you ready? You can begin your presentation.
Yeah. 1 minute.
So, Aishwarya is here to share her presentation on H-alpha spectroscopy of emission line stars.
Good evening, one and all. My name is Aishwarya, and my project topic is alpha spectroscopy of emission line stars. First of all, we have to know what is astronomy. It was simply defined as study of stars, planets, and space. So next, what is a star? A star is a big ball of burning gas, and it can produce tremendous amount of energy. And mostly these hydrogen and helium are held together by its own gravity. The nuclear fusion is the main reaction that we can see on stars. Next, this is one of the important mnemonics which is used for to classify the stars, because in our universe they consisting of many there's lot of stars. So this OBAFGKM is one of the mnemonics, and here OBAFGKM is a spectral type, and our project is based on the stars belong to B and the A type spectra. So the stars are mainly observed as a 3 type of spectra. Either it is continuum or emission or absorption line. In the case of an absorption line, if we consider a one source, and if the light is passes through a cold gas, then the atoms in this gases is absorb the photons, and it shows as the dark band. And in the case of emission line spectra, if the light passes through a hot-ing gas, it emits a photon, and the corresponding lines appear as an emission line. And in the case of a continuous spectrum, if we using a high intensity or high pressure gas, then the emission lines are become so broadened, so we can distinguish any line, so it produces as an continuous spectrum. So this is the one of the main important topic is the emission line stars. Emission, the stars are mainly seen as absorption line, but few stars can show those emission lines, and they can also show the variability of long-term and short-term variation. It is one of the important characteristics, and they are also originate. These emission lines are originate in 3 ways. This is stellar type or stellar activities and binary interaction. Again, the stellar emission lines are divided into 4 types: late, close binary, pre-main sequence, and early type stars. And our project is based on this early type stars, which is again divided into classical and Herding AE or BE stars. So now we have to see how those emission lines are formed. If an electron is excited or transmitted from higher energy level to lower energy level, it emit a photon, and which gave rise to the emission lines. So here in the case of stars, we consider if the transitions take place from n equal to 3 to n equal to 2, it produces a photon of wavelength 656 nanometer, which is corresponding to the H alpha emission lines. And it was the most strongest emission line that we can see in a star spectrum. And from for in the case of n equal to 4 to n equal to, it produces H beta and H gamma. Other than this, these emission lines are consisting of two type permitted lines and forbidden lines. For permitted means if the transitions are possible, that means from higher energy to lower energy level, hydrogen and helium like lines are produced. If the transition is not possible due to some selection rule, in cases they produces the forbidden lines. So now we have to see what is classical B stars. It was a massive B stars of luminosity between 3 and 4, and these classical B stars are considered as the rapid rotators. That means they can rotate up to a critical velocity, but actually it was not proved how they travel with this rapid velocity, but we can explain it some of the terms by using the gravitational darkening, and they can also produce these like H, Fe, He and Ca, calcium, that is hydrogen, iron, helium like emission lines, and among them H alpha is the strongest one. And from the picture we can see that the stars are surrounded by the thin gas disk in near Keplerian regions. And there is also a controversy that how the if we see stars at one time with a disk, and if we observe the same stars at different time scales, they disappear this star disk. So it was also a new topic. And next, the Milky Way galaxy. In our Milky Way galaxy, there are 20% of stars are classical B stars, and their properties are mainly strong H alpha and short term and long term variation. In here, in the case of H alpha emission, if you observe this is the star, and if you observe the star from different position A, B, C, D, A corresponding to I equal to 0 degree and B corresponding to negative degree, and B and C in between the positions, we get a single peak, double peak and a shell type star spectrum. And another property is the short time variation, and that means the stars changes its shape or shape according to short time variation, that is in a small time scale. It was either due to pulsation, rotational modulation or transient features. Next is the long term variations. Those long time variation means the stars show variation over a long range or several decades, etc. It may be due to phase change, V by R variation. V by R means violet to red variation, that is there are two peaks here. First peak corresponding to violet and second peak corresponding to the red, and the transition profiles. Next is the Herbig AE or BE stars. It was an intermediate three main sequence stars of luminosity between 3 and 5. And they, from the picture it is also sees that this stars is also surrounded by the gas dust, and they consisting of the equatorial disk, which is the remnant of the star formation. And the main emission line that we can see in a Herbig A or BE stars are the calcium and the hydrogen lines, and they have 2 to 8 solar masses. And other than the classical B stars, it have some more important properties, that infrared exists due to the presence of this dust shells and around the stars, and time variation. That means they show variation in their brightness and spectral features, and they have the linear polarization of about 7 to 8%, and that of the classical B stars is about only 1%. And the association with the forming region, that means it was related to the bimolar variation. Now the analysis and observation. Here we take 40 classical B stars and Herbig stars for the for analysis. So the entire 40 stars are divided according to these 6 type of spectra, and here this is the morphological classification. The spectra that we obtained from our analysis is either single peaked, that is this one, and this is asymmetric structure is this type 2, and double peaked type 3, and its asymmetric structure is type 4, and p-zygenic profiles, and most of the few stars are show these p-zygenic profiles, and the unclassified group which belongs to the combination of all these stars. And when we observe the star spectra, we can see like this, and here the stars which having highest emission occur, which is the H alpha, and there are some emission that we can also see along with this spectra. It was corresponding to some metallic lines or some H alpha, H beta or H gamma, H delta, something etc. So these are the some of the wavelength corresponding to the formation, that is Fe2, Si2, Mg2, etc. Next, so the methodology. Here we take 20 classical B stars and 20 Herbig A or C B stars from the best database, and we obtain a medium resolution spectrum of these 40 stars between the range of 3,800 to 9,000. And the data, the catalog is converted into normalized spectrum by using IRAF or Python programming analysis. This is the best database, and this is the home page of best, and here we can find the spectrum by using this home page. Here we get stars only from B stars and only B stars. These are the samples that we have taken. That is the name and spectral type of 20 classical B stars and 20 Herbig A or B stars. Here I'm explaining only one type. This is Gamma Cassiopeia. Gamma Cassiopeia is one of the main important stars in the alpha destination, and it is an eruptive variable star. Color is blue, and this HD and BD number indicate the star number. We can only find a star using this HD and BD number. HD means Hendra Dapper number, and BD means Bayer classification number. And this is the major result that we get from the analysis. Here I divided the entire 3,800 spectra to 9,000 Armstrong spectra into 6 type. From here, the first range, if we compare all these 6 spectra, we can see that this last spectra is with having a high flux of 5. That is the strong H alpha produces, which is corresponding to a wavelength of 6,569, and here the wavelength next highest is the 1.6, that is this third picture, which is corresponding to H beta, and the next highest is the 1.2, which is corresponding to second picture. It is the which indicate the emission of H gamma emission, and the absorption line. Here there is one absorption, 1, 2, 3 absorption lines in the first picture corresponding to Fe emission, that is metallic emission lines, and the picture 4th and 5th also indicate the H alpha emission, metallic emission and absorption lines. So this here I give that two the Gammas are observed at the 2 dates of 9/9/2090. Here at this point we get H alpha emission as a very peak one corresponding to this wavelength, but we observe the same star after 2 months, that is 2120, we get this peak emission is broadened like this. That is it shows a short time variation. That is the classical V stars are changing according to the time scales. Now the conclusion that we have to observe from here, the star spectra possess both the emission and absorption lines, and also with the emission. In emission they can also possess this absorption line, and the H alpha is the prominent feature of this classical V stars and Herbig AE or B stars. And the prominent lines that we detected from this 40 stars are Fe2, Si2, helium and oxygen. And C2 Ceti is the one of the important stars, which actually it shows double peaked absorption at first, and after 1 decade it shows it changes into double peaked emission. That is a clear case of disk formation. And these are the some stars which showing the long term variations and short term variations. So let me conclude my section. Thank you.
Thank you, Aishwarya. You have presented very well.
Yeah, really, it's a very good presentation, Aishwarya.
Thank you, ma'am.
Yeah, just I do have got a very basic question from your part.
Yeah.
Yeah, have some water. Have some water.
Yeah.
Yeah, it was a wonderful and interesting presentation. But
Yeah.
only one basic thing, Aishwarya, and you said that these stars are emitting different elements, and among
Yes.
those elements, that is hydrogen is dominant. Can
Yeah.
you tell me how all these elements are emitted from such stars? What is the
Yeah.
process behind this emission?
Actually, ma'am, in the stars, from the core of the stars, they can produce the gas ejection is always take place. So, when some gas ejections, which will lead to the formation of some like metallic lines, and mainly the hydrogen. That means, in the case of nuclear reaction, we get mainly hydrogen and helium. So, H alpha become the most prominent. That means, hydrogen lines are most prominent in these stars.
Okay, good.
Yeah.
And whether all this kind of emissions are time dependent, that is either it depends on the climate or what are all the factors that it may change this kind of emissions?
Actually, ma'am, the emissions are mainly depend upon one time it's about its disk. Actually, there are many questions and research are based on this, how the disk are disappeared and how they occurred. Actually, I don't know correct answer that because it was a research topic. And next,
No, as you said,
Okay.
the answer is in the first part. That is the emission of the elements. It just depends upon the nuclear fusion. That's all.
Yeah.
So yeah, it is not just with respect to timeline or climate. It just depends upon the temperature at which the stars are taking place. So the main thing is the fusion and the temperature plays the dominant role in emission, right?
Okay. Yeah.
And yeah, and what
Yeah,
is
this is-
that's all in my part. I think Dr. Emima may ask the question.
Okay.
Aishwarya, thank you, ma'am. Aishwarya, that was a
Thank you.
wonderful presentation.
Thank you, ma'am.
Aishwarya, I have a doubt. You have said about forbidden transition and permitted transition, right?
Yeah. Yeah.
So, in your case, can you tell me what are all the forbidden transitions? Like a selection rule, do you have?
Yeah, ma'am. According to the magnetic lines, they in some stars they don't have to, they can't emit an electron to ground state. In such cases, they use the magnetic dipole interaction. So in such cases, the forbidden lines are formed.
Okay. Then in your graph, I can see your x-axis. X-axis is
Last-
wavelength. And what is your y-axis?
It's a wavelength. Yeah, is
No,
this?
your x-axis is your wavelength, not the 6 graphs at the last you had, right?
This one?
Yeah, that one, exactly.
Yeah, okay, okay.
What is your y-axis? What is the parameter in your y-axis?
Flux, normalized flux.
Okay. You haven't mentioned it, I think. It's better to put it there.
Yeah, there is not enough space, so I just cut it.
Okay, that's not a problem. I just want to know. Okay.
Okay.
Thank you.
Okay, ma'am.
So thank you, Aishwarya, for your wonderful presentation.
Okay, thank you.
So next, I invite Vaishna PYPG002. I think she's not there due to some problems. She said to postpone her presentation. So now I call the third student, Gianni Maria Matthews, number 4. PYPG004.
Good afternoon, everyone. My topic is study of latitude and longitude dependence of number counts of stars and galaxies within the solar neighborhood. Solar neighborhood means stars and galaxies within the solar neighborhood means stars and galaxies within the 15 light years around the sun. And we know astronomy is an natural science that studies celestial objects and its phenomena. It uses physics and mathematics and other sciences to explain. As is an important characteristic of our modern astronomy, and with the help of multivariate astronomy, we are able to see our universe in its full glory. And here we, in our project, we use ultraviolet astronomy, and it is the study of ultraviolet rays in the electromagnetic radiation from 10 nanometer to 400 nanometer. Mostly ultraviolet observations are made from the space. It's because it's not done from the earth. It's because the atmosphere will absorb the UV radiation, and we don't get a good data from it. And why UV astronomy? What is the importance of using UV astronomy? In fact, UV radiation is a segregation of hot objects. That means the stars or galaxies in the early or late stages of their evolution produce UV radiation, and also we can study most of the energy transfer in the stellar medium, and also we can track the transfer of radiation from stars to interstellar medium. That is, we can study the diffuse UV radiation. And we here take the GALEX data. GALEX was GALEX Evolution Explorer, and it was a NASA Small Explorer mission. It was launched in 2003 and it was decommissioned in 2013. It was the first all-sky wide ultraviolet survey. And there are some specialties for GALEX. We have a direct imaging and a vision in two broadbands, means in far UV and in near UV. Far UV is in the range of 1344 to 1786 angstrom, and also near UV is in the range of 1771 to 2831 angstrom. And our GALEX is a small orbiting space telescope, nearly circular low at orbit with a mean altitude of 690 kilometers. And we select some of the data from the GALEX data, and it was we take a 16,000, and it was some GALEX GR6 GR7 deep image survey, and this is the most recent and completely available data from the GALEX. When we select data from the GALEX, we have to consider that whether NUV and SUV observations exist, and if they exist, their exposure times must be large. And these are the target names we selected, and they are galactic longitude and latitude, and also their exposure time and visits. We can see that in the target A, there's SUV exposure time is 0, because SUV sensor was damaged before it was decommissioned in 2013. And this is the location of the selected target, and we can see that all the targets are spread all over the sky. So we can give an overall picture of the sky. And here our methodology. First, we then that GALEX data we can be obtained from the NASA Mars archive. Then we selected the source with field of view of radius less than 0.6 degree is considered for the analysis, and then from that we separate NUV and SUV data from the entire merged catalog, and then within them itself GALEX and star data were sorted and listed using proper conditions, and then the stars, the fifth step is the stars and galaxies of both NUV and SUV were tabulated into classes according to their magnitude. Then we average it. Then the number counts of stars and galaxies is calculated. Then their n per degree square is calculated. Then we take its logarithmic value. Then counts per second is calculated. From all this we calculated the total flux and the flux intensity. In each step, we done it for both NUV and SUV data. Therefore, for in NUV for stars and galaxies, and also for SUV in stars and galaxies. Then we plot a graph between logarithmic number value and the AB magnitude for the 16 observations. And then to study the latitude and longitude dependence on number count, we plotted 8 graphs. That is NUV stellar magnitude versus number count for galactic longitude and latitude. Similarly, NUV galactic magnitude versus number count for galactic longitude and latitude. FUV stellar magnitude versus number count for galactic latitude and longitude. FUV galactic magnitude versus number count for galactic longitude and latitude. And here is the plot for latitude dependence of number count. And here we can see that this is for the NUV star magnitude versus number count, and it shows a linear dependence. We can see that it's linear in shape, and in the case of when we plot for SUV stellar magnitude versus number count, we also get the same linear dependence. Then this is for NUV GALEX magnitude versus number count. Here we get a nonlinear relation. Similarly, we got a nonlinear relation in the case of SUV Galaxy 2. That is, from the latitude dependence plot, we get NUV and SUV stars plots shows a linear dependence with magnitude. NUV Galaxy and SUV Galaxy shows a nonlinear dependence, and we can also able to see a flipping effect in it. Then, to study the longitude dependence of number count, from the graph we get this is a plot for SUV star magnitude versus number count, and it shows a nonlinear dependence. Similarly, we get for NUV Galaxy, and this is the case for SUV galactic magnitude versus number count. Here we got a linear relation. Similarly, we get for NUV star 2. That's from the longitude dependence we get NUV star and SUV Galaxy plot shows a linear dependence with a magnitude, and NUV Galaxy and SUV star shows a nonlinear dependence with a magnitude. Then we are moving to our result. That is, in the case of latitude dependence, NUV star and SUV star shows a linear dependence when we plot for, as earlier said, when we plot for galactic magnitude and for logarithm value. And for NUV Galaxy and SUV Galaxy, we get a nonlinear relation. In the case of longitude dependence of number count, NUV star and SUV Galaxy shows a linear dependence, and NUV Galaxy and SUV star shows a nonlinear relation. And also from the intensities, total intensities calculator, we get that number counts of bright stars are more in the lower latitudes compared to other latitudes, whereas faint stars are more in high latitudes. Then flipping effect is noticed in the study of latitude effect, and also flipping effect may be due to the observation due to the closeness of galactic planes, where most of the interstellar gas and the dust deposits. And we are doing our future works in it. That is the latitude and longitude effect on total intensity. Similarly, we are taking the data of IR telescope, that we get a better understanding of the selected area. And also further studies we are doing by comparing Astrostat and Hubble, other UV telescopes, and some references. And thank you all.
Yeah, it's a very good presentation, Marin K. Joy. Yeah, I do have got a very basic doubt. There is, as you said, there is some latitude effect and longitude effect, and how there is, you mentioned about some counts at the last. What type of counts will it be taken for calculations? Whether that is because you are able to, yeah, please.
We take the number counts of, we selected a particular area and we calculated the number of stars and galaxies in that area, and by plotting it against their AB magnitude, we get a relation.
Yeah, actually, what you are relating is there is the number of counts is proportional to the bright stars which is present. Are we recording any luminescent property, light properties? How do we correlate the counts with the light?
We are not relating counts with the light. We calculated total intensity for each area in each tile. Then from that intensities we can say that in the result we can say that number counts of bright stars are more in the lower latitude.
Okay. So,
bright stars are
See, actually, brightness is the factor which could be determined only by the absorption, right? But depending upon the location, depending on only the location, we can't just list down with the brightness, right? So, do we have got any solid evidence to show that it is just a bright star which is presenting in the lower latitudes?
Ma'am, these are all our assumptions. This may be due to the obstruction of the galactic of the interstellar gas or dust deposits. These are
Yeah,
only
good.
our assumptions.
Okay.
We are doing further studies to understand.
Okay, fine. So better experiments are needed to counter all this kind of
Yes.
conclusions. Right, good. And
Yes.
another more question. There is, as you said, that there is some linear dependence for stars and non-linear dependence for galaxy. Why that variation is there? Because we are going to collect only the countings and how this variation is there, and when you compare with the stars with the galaxy.
We just, ma'am, it's a
Yeah.
kind of study to, can you repeat the question please once more?
No, actually you're concluding it as that is a linear dependence for the latitudinal effect of stars and non-linear dependence for galaxy. My question is how this variation occurs, because both are going to be the star dependent property. How this latitude effect varies in this both the cases?
Ma'am, we just find there's a variation like this, and we are doing the studies on it. Why it shows there's a change, or that shows a linear or a non-linear variation by plotting this. We just consider how to see how the variation is, and we don't know what's the reason for that variation. We are doing further studies on it too. Find it.
Okay, ma'am. Thank you, dear. Thank you, ma'am.
Thank you, ma'am.
Malin, that was a wonderful presentation. I just have only one doubt. You have chosen in your methodology, you have given, right, the region is lesser than 0.6 degrees.
Yeah.
And what is the reason? Why you have chosen that region?
Ma'am, mainly this target is of radius of 0.625 degrees. Then we are limiting our radius to 0.6. This is to avoid the edge effect. Maybe this other edge effect means വേറെ സ്റ്റാർസ് അല്ലെങ്കിൽ ഗാലക്സീസിൽ നിന്നുള്ള റേഡിയേഷന്റെ എഫക്ട് അല്ലെങ്കിൽ ഇൻസ്ട്രുമെന്റിന്റെ എറർ കൊണ്ടൊക്കെ അതിന്റെ സൈഡിലുള്ള ഡാറ്റാസ് കറക്റ്റ് ആവണമെന്നില്ല. To avoid that, നമ്മൾ റേഡിയസിനെ ലിമിറ്റ് ചെയ്യാണ് ചെയ്യുന്നത്.
So from your literature, by going through your literature, that you are saying that this is the best region.
Yeah.
Okay. Thank you. Thank you.
Thank you, ma'am.
Thank you, Merin, for your wonderful presentation. Now next I call number 7, Srijana Raut, PYPG007.
Hello everyone, present I am Srijana Raut and I present before you my work on classification in heavy ion reactions at near barrier energies. I have done this work under the guidance of Dr. E. Prasad at Department of Physics, Central University of Kerala. So before I go into what exactly is quasifission, it is of utmost importance to know why we are interested in quasifission. Well, that brings us to super heavy elements. Liquid drop model forbids the stability of any element having atomic number greater than 100. But super heavy elements having atomic number greater than 104 are synthesized to exist in libraries, even though very short-lived. And the heaviest super heavy element synthesized to date is organesson with atomic number 180. The unique thing about SHE was that the stability of SHEs can be attributed to the shell structure. The synthesis of SHEs is a very cumbersome process. It takes years of meticulous research to produce a single nuclei through the only approved method of fusing two very heavy nuclei, which we call as heavy ion reactions, even though other methods like transfer fission reactions exist only theoretically. For example, I can take two nuclei with atomic number 60 each to form Z equal to 120 nucleus theoretically. And in this, we have represented a crude blueprint of how a heavy ion reaction processes. But the path to SHEs is not as smooth as I just dictated before. This is because of the presence of a very unique and very mysterious hindrance known as quasifission. The process of reseparation of the DNS or the dinucleus system into two fission-like fragments even before it equilibrates to form the compound nucleus is called quasifission. That is why we have named it quasi. Quasi meaning apparently, not really, as it gives fission-like fragments, not exactly fission fragments. It shows dependence on a number of factors like charge product of the system, mass asymmetry of the entrance channel, beam energy, etc. And the catch about quasifission is that in a heavy ion reaction, the cross section of quasifission is very high compared to true fusion-fission cross-section or even fusion cross-section. So the previous blueprint which I just showed to you now becomes more complex than ever, because the point of dinuclear system now bifurcates into either the formation of compound nucleus or it can just undergo quasi-fission. The relation between mass angle correlation of the fission fragments and quasi-fission is very unique. So once the dinuclear system is formed, it rotates through an angle theta for the conservation of angular momentum. So the larger angle it rotates before it reseparates, more mass is exchanged. This is depicted in the figure, schematic diagram shown on the right hand side of the slide. And after it reseparates, this angular anisotropy is very much evident in the mass angular distribution of the fission fragments. And this is a conclusive evidence of presence of quasi-fission. Moving on to the process of our study, the experimental data was obtained by my supervisor, Dr. E. Prasad at Australian National University, and this analysis of the data thus obtained is the pinnacle of my study. The first step towards it is the position calibration of the raw data, which is nothing but the separation of the unphysical events from the three-body events that was in the and the three-body events from the raw data, and to calibrate the xy coordinates into theta phi coordinates, and thus reconstructing the kinematic velocities of, along with timing information. The next step is the time calibration, which is nothing but determination of two time constants, namely delta t and t0, which once determined, we can move on to the method of either time of flight or time difference and find out the mass ratio of the individual fission fragment mass. Once this is done, we can go for minute gating to filter out the full momentum transfer events or the binary fission events. Once this is done, we obtain a refined MAD which looks like this, and the high intensity plots on the lower mass side it represents the projectile like fragments, on the higher mass side it represents target like fragments, and in the middle you can see there is a notable tilt in the mass angular distribution which arises due to the presence of non-equilibrated events like quasi-fission. If this was pure true fission, then it would be much narrower and there would be no tilt observed, but in this case there is a notable amount of tilt, but we can't say how much exact quasi-fission is present in here from this value of from this figure itself. We will move on to the process of determining that in the later slides. This brings us to our results and discussion. We have mainly studied three systems: 40 calcium on 186 tungsten, 178 hafnium and 176 ytterbium at 4 different values of beam energy, which lie in the vicinity of barrier potential, around 12% of barrier potential, plus or minus. So in this you see that this MAD plot for the calcium plus 186 tungsten reaction, and the upper 4 panels are the MAD plots obtained at the increasing values of beam energy, whereas in the lower 4 plots are the projection of the MADs onto the x-axis to give us the mass distribution curve. The blue ones are the experimental ones, whereas the red one is a theoretically obtained mass distribution curve which takes only fusion fission into account. This is the same for 178 hafnium. I hope the observer will note that there is a significant difference in the mass width of the mass distribution curves, and this is same for 176 terbium. So once we minutely study the width of the mass distribution curves, we see that the 3 nuclei show 3 different trends corresponding to their theoretical counterparts. Even though there is a distinctive amount of difference in mass widths, the 3 nuclei, 186 tungsten actually shows a steady decline in mass width, whereas 176 terbium and 178 hafnium remain almost constant. On the right hand side panel, you can see the minimum probability of quasi-fission, which actually tells us how much quasi-fission is present in the reaction. So in this kind of reactions, we can theoretically expect that the fusion fission will be around 100%, but in this case we see that the quasi-fission itself takes up around 40 to 50% of the reaction. This is a comparative study which says which tells us how with decreasing value of charge product there is a decrease in value of minimum probability of quasi-fission. So as we see from 186 to 176 terbium, there is a decrease of minimum probability of quasi-fission from around 52% to 40%. So that brings us to a conclusion that the notable tilt observed in all the 3 reactions is a conclusive evidence for the presence of quasi-fission. And as we consider more and more heavier system from 176 terbium to 186 tungsten, the charge product or Coulomb factor plays a very deciding role in determining how quasi-fission will act with increasing values of beam energy. So there is a clear dependence of quasi-fission on beam energy as well as Coulomb factor. If we note upon the individual trends of nuclei like 176 Dept, which actually shows increase in coefficient with increasing value of beam energy, that nature can be attributed to the orientation of the long axis of the nuclei, and certain bizarre tendencies can also be attributed to temperature of the nucleus and increasing deformation parameters. Future perspective of this research includes a detailed study onto this explicit factors to understand how exactly these factors influence precipitation in a reaction, so that super heavy elements can be probed in for greater gain. Thank you so much.
Yeah, it's really wonderful presentation, Srinjana.
Thank you.
Just one basic thing, and that is, what is the major reason behind this quasi-fission reactions?
So ma'am, basically what happens once in a heavy ion reaction, we are taking a projectile which is quite heavy, means it is heavier than an alpha particle. So in this case, like we have taken calcium 40. So once it collides, goes into reaction with a heavier nucleus, like in this case 186 tungsten, then once they form the dinucleus system like this, I hope you can see that it forms a dinucleus system like this. Even before it rotates to form the compound nucleus, equilibrate, it actually re-separates due to the Coulombic repulsion. That is what we are showing by the value of charge product. Means if charge product is too large, charge product is nothing but the product of the atomic number of the two nuclei involved in a reaction. That shows us how strong the Coulombic repulsion is in a system. So with increasing Coulombic repulsion, the DNS will tend to separate more often. That is the basic idea behind quasi-fission, but there are other factors as well. As I have already told you that for certain orientations of the reaction, like in this case, quasi-fission is actually favored in axial collision. So if the nuclei is oriented like that, so it will be much more easily favored. Quasi-fission will be favored over true fusion fission. And several factors like temperature of the nuclei, how much the nuclei is deformed, as well as how much energy we are putting into the projectile is also important in determining quasi-fission.
Yeah, good. Thank you, Srinjana.
Thank you.
Srinjana, that was a crystal clear presentation. I just have only one doubt.
Yes,
Can you tell me the difference between fission and quasi-fission?
Yes, ma'am, sure. Actually, we all have studied Bohr's compound nuclear theory, right? So, in Bohr's compound nuclear theory, what happens once the compound nucleus is formed, it completely forgets its history of formation. Means it re-separates, means it fissionates into completely two different fission fragments which have no memory of their parents whatsoever. That is Bohr's compound nuclear theory, that its decay is independent of its formation. But in quasi-fission, what happens? The fission fragments, which resembles kind of fission fragments because they are not they don't exactly weigh or look like their parents, but they have mass similar to their projectile or target. Means if a 40 calcium and a 186 tungsten is in play, then the quasi-fission fragments will have mass similar to 40 and 186 tungsten, maybe around in the range of 190 and 50 or something, which shows that it retains the memory of its parent nuclei. That is the difference between quasi-fission. Means those are not exactly the nuclei we put into the reaction, but different nuclei, but not exactly new nuclei what we will expect from a compound nucleus fission. That is true fission.
That was wonderful explanation. Thank you, Ma. Thank you.
Thank you so much.
Thank you, Srijana. Your explanation was explicit.
Thank you, ma'am.
So now next I call the next student, Veena K. Kumar, PYPG008.
Good evening all. Myself Veena K. Kumar and my topic for the presentation is towards the development of copper tin sulfate nanoparticle as an earth abundant photovoltaic absorber. We all know that due to vast environmental issues and emerging energy crisis, it is indeed to find new energy sources like solar energy on higher priority. And as we all know it, It is the one of the good and viable source of renewable energy. So far, a photovoltaic system which employs a solar energy uses solar energy for its operation. But recently, film solar cells have achieved wide attraction. It is because of their efficiency in operations as well as in low cost in a simple structure. Copper tin sulfide is a p-type semiconductor material which is having a great attention due to its properties like low cost, low toxicity, eco-friendly, availability of materials, easy to synthesize, better photocatalytic activity, photovoltaic property, and also it exhibits electrical and optical properties. That is why the aim was targeted to synthesize copper tin nanoparticles by using a simple, facile and eco-friendly photothermal method. Moving to next slide, experimental procedure. Here I took 3 chemical reagents, copper acetate, stannous chloride and thiourea in the ratio 1:1:2, and these reagents completely dissolved in 20 ml of ethylene glycol by using a magnetic sphere. Then this mixture is transferred into a Teflon-lined stainless steel autoclave and heated at different temperature for 24 hours. Thus the obtained product were centrifuged and washed several times with deionized water and ethanol, and thereby the product was kept for drying at 110 degrees Celsius for 24 hours. The finally obtained product is studied by the following characterization technique like XR, scanning electron microscope, FTIR, ultraviolet visible spectroscopy and PL spectroscopy. On coming to the XRD analysis, the spectrum of all the 4 samples confirmed the formation of highly crystalline orthorhombic copper tin sulfide nanoparticles with a sharp peak, and the average crystal size for each sample can be calculated from the D/Scherzer equation as given here. Next, moving to the SEM analysis. Surface analysis of copper tin sulfide says that the surface morphology of copper tin sulfide is notably influenced by the reaction temperature. Here the SEM images are shown for different reaction temperature. When we look into it, it can be seen that when the temperature increases, the structure becomes self-assembled to form flower-like nanospheres. Next one, FTIR result. Here the 4 FTIR spectrum are given for different reaction temperature. From the table, we can see that the peaks around 1620 centimeter inverse is erased due to the presence of delta NH2 vibration. Similarly, the peaks at 3382 centimeter inverse and 3375 centimeter inverse are due to the NH stretching vibrations, and peaks at 1379 centimeter inverse is due to the vibration of CS bond, and also the peak at 1022 centimeter inverse is caused by the SNOH, and peak around 1618 centimeter inverse shows the presence of copper sulfide stretching modes. From these data, it can be clearly indicate that the synthesized product is composed of copper tin sulfide nanomaterials. Moving to next slide, the optical analysis. Here both the absorbance and the transmittance spectrum of copper tin sulfide is given for different temperatures. And in the absorbance spectrum, it is clear that the obtained copper tin sulfide has higher absorption in the visible region, whereas transmittance is lesser in the visible region, and absorption begins in the UV region and increase and become maximum in the visible region and near the IR region. So from this analysis we can say that copper tin sulfide is a good absorbing material. On coming to the PL result, here the emission was obtained at an excitation wavelength 400 nanometer, and from the spectrum the sharp and narrow peaks indicates that synthesized product is formed with larger confinement and with less impurities. On looking to the spectrum, all the four temperature gives a cutoff wavelength of 804 nanometer in the IR region. And also the band gap energy can be calculated by the equation given here, and it is found to be 1.54 electron volt, which is consistent with the reported values. So I am concluding my section. In the present work, flower-like structured orthorhombic copper tin sulfide nanoparticles were synthesized via simple facile solvothermal method, and the obtained sample is characterized by studies such as XRD, SEM, FTIR, UV visible spectroscopy, PL spectroscopy respectively. And from XRD analysis, it is found that the crystal size increases considerably, and it with the reaction temperature, and the crystal structure is orthorhombic. From this SEM analysis, it is found that surface morphology becomes self-assembled when increasing the reaction temperature. From the optical analysis, it clearly gives that the copper tin sulfide nanoparticle has higher absorption in the visible region and lesser transmission in the visible region, and the sharp and narrow peaks in the PL analysis or PL spectrum indicate that synthesized product has larger confinement with less impurities, and it is found that band gap of the copper tin sulfide nanoparticle is 1.54 electron volt, which is consistent with the reports, and the above mentioned characterization result exhibits that copper tin sulfide is a good photovoltaic absorber. Thank you.
Yeah, it's really a very good presentation, Veena.
Thank you, ma'am.
Yeah, I do have got one doubt here. That is, as you said, you have prepared the copper tin sulfide nanoparticles, right?
Yes, ma'am.
Yeah. How much amount of molarity have you considered to prepare this? Is any mole-wise preparation were followed? Yeah.
It's small wise preparation. We take the chemical reagents in 1:1:2 ratio, ma'am.
Okay.
And in mole ratio.
Okay, in mole ratio. You're not taken in the weight percentage.
Yeah, by calculating, putting the mole into the equation, and we calculated the weight.
Okay. No, the basic doubt what I would have is, since you're introducing tin in the copper sulfide structure, or in other words, I can say that you are introducing copper in tin sulfide structure, right? So why don't these nanoparticles can be referred as a dopant or composite?
Miss, costume once more, please.
Yeah, do you want me to repeat again, dear?
Yes, ma'am.
Yeah.
Yes.
It's not
See, actually, what you have prepared is, it is a mixture of two elements, right? We can also assume in this way, you are introducing a tin in copper sulfide structure, or in other words, you are introducing a copper in tin sulfide structure, right? Instead of having a nanoparticles, why don't we mention this as an nanocomposite or nanodopant?
We only prepared the nano powder form, ma'am.
Okay.
In the nano powder
Okay. See, actually, copper sulfide alone is a nanopowder form, tin sulfide is a nanopowder form, but here you are fusing two different elements in one single structure. So we need to consider that whether it is a dopant or the composite. If you dope it in the lower level, that is up to 5%, that is up to 0.05%, it becomes a dopant. But as you said, you have doped about 1:2 ratio, right? So it becomes a nanocomposite rather than the nanoparticle. Okay, anyway, it is left to you and you can decide, but anyway, this is one such of nanocomposite thing. Okay, fine. And another question is, you have mentioned about the band gap, whether it is a direct band gap material or it's an indirect band gap material. You mentioned that some band gap is 1.54 electron volt.
It's direct band gap, ma'am.
Yeah. Is the direct band gap materials are suitable for the photovoltaic sensors, dears?
Ma'am.
So actually, Veena, the answer is it may not be the direct band gap. If you go and analyze, it can't, because you are fusing two different elements into one single crystal structure, right? As we said in the beginning, you are introducing copper into a tin sulfide, or you are introducing a tin into a copper sulfide. So in that case, we can't have the direct band gap. Only we do have got an indirect band gap. If you go and analyze clearly, you will be end up with this conclusion. One thing. And second thing, and the indirect band gap nanostructures might be it shows a good photovoltaic absorbing property, but it can be enhanced only with the help of the catalyst. It can't alone can be used. But anyway, you have not touched the photovoltaic property, so we no need to worry about it. Okay, anyway, thank you so much, dear, for your wonderful presentation. Thank you. Thank you. Over to Emima.
Thank you. That was a good presentation, Veena. Can you go to the XRD slide?
Yes, ma'am. Can you see it?
Yes. I can see. Yes. Okay. Here you have mentioned clearly, as the temperature increases, your crystallite size is increasing, right?
Yes, ma'am.
Now, what about in the case of band gap? What happens in the case of band gap when you increase the temperature?
When we increase the temperature, the band gap will also increase, ma'am.
So you have your UV graph, right? You have your UV graph. You have 4 absorption graph, right? UV visible absorption spectrum.
Yes, ma'am.
Yes. Go to your UV. Yeah. From this, you have to calculate your band gap, right? Using tau plot.
Okay, ma'am.
You have to do that, and you have to tell 4 different band gaps. What? I couldn't get you, Veena. So now you have to mention how the energy gap is changing with respect to temperature.
Okay, ma'am.
Okay, because you're talking about photovoltaic properties. What, Veena?
I have taken band gap here, calculated here.
Oh, you have. Where is it? Yeah, I have only one band gap there. You have mentioned only one. But you have 4 different samples with different temperatures. This is using different temperatures, right? So how the temperature is affecting the energy band gap? You need not worry about that. I'm just telling you that you have to calculate that too.
Okay, ma'am.
Okay, because you are going to use this for photovoltaic application, then you have to know how the energy gap is also changing according to temperature. changing according to the temperature.
Okay, ma'am.
Okay? Okay. Thank you.
Okay.
Okay? Okay. Thank you.
Thank you, ma'am.
Thank you, Veena. You have presented very well.
Yes, ma'am.
Thank you.
Yes, ma'am.
So now I think Gianni is ready with her presentation. So I invite Gianni Maria Matthews, number 4, to present her research project.
Yes.
Can I present now?
Can I present now?
Yeah, you can present.
Ma'am, can you see the...
Yes, you can begin. Yeah, you can begin. Yes.
Can you see it now, ma'am?
Can you see it now, ma'am?
Yes.
Continue.
Very clear.
Yes, continue.
Recovery of trout to vibrant plain is literally our generation's greatest challenge. On that note, I extend a very warm good afternoon to one another. Myself, Gianni Maria Matthews. Today, I am here to make a presentation on the topic Investigation of Microclimate of a college campus in South India based on EMISSION model. We are all quite familiar with the term urbanization and its pros and cons. As a matter of fact, urbanization has a profound effect on mankind. Rapid growth significantly alters the natural environment and leads to distinct urban climates. Urban geometry is one of the most important factors that cause the urban-rural and intra-urban temperature differences. The characteristics of climate of any region is certainly influenced by building form, urban configuration, as well as selection of construction material. Moving on to the research objectives, this paper investigates the ambient air temperature variation under different underlying surfaces in the campus of Catholic College Pathanamthitta in South India during winter and summer season. Microclimate simulations were carried out using ENVIMET. Based on the ENVIMET simulation, we have proposed a strategy to mitigate the heat accumulation. Now, let's have a look at the methodology that we have adopted. 4 locations within the campus were selected to study the ambient air temperature variation under the different underlying surfaces. The surface temperature and the ambient air temperature were measured under clear sky and low wind on 13 December 2019 and 19 March 2020. Surface temperature was measured using an infrared thermometer, and the air temperature was measured using a high-resolution RTD card. It was placed in a Stevenson screen at a height of about 1.8 meters. The software that we have used here is ENVIMET. It is basically a 3-dimensional computational fluid dynamics non-hydrostatic model. The modeling program has 4 kinds of user interfaces. The first one is editing the input of prepared digital maps of the layout of the domain. The second interface is the configuration editor. The third one is modeling area input file. And the fourth is the one in which the data can be interpreted and visualized in Leonardo. The ENVIMET simulations were carried out for a period of about 24 hours, and 2 simulations were carried out. And the first is the one with unmodified building surface, which can be seen on the left-hand side of the slide. The image is seen over there. And green ball building morphology is the second one. The image of the simulated image of college with green balls is given over the right hand side. Now moving on to the location details.
Location A is an interlock concrete tile surface exposed to sun, which is surrounded by two-story flat building. Location B is a surface with asphalt, and location C is an exposed soil surface in open ground, and location D is a shaded interlock concrete tile surface with vegetation cover near the auditorium. Now, here we have the map of the study area, in which all four locations are clearly demarcated using red spots. And moving on to the next aerial view of the locations is given over here. And here comes the ground view of locations. Here we have the results that we have obtained through our study. Surface and air temperature showed remarkable variation in 4 different locations. There are 2 sets of temperature versus time graphs, and the first set shows the surface temperature variation in 4 different locations during both the seasons, and the second one shows air temperature variation during the summer and winter season. The surface and air temperature was found to be high over the low albedo materials like asphalt and concrete surface, and it is low over the surfaces like open ground and shaded tile surface. Now let's take a look at the NDMET simulation results that we have obtained. Simulation was carried out for 24 hours on 13 December 2019. The results for 10 AM, 2 PM and 6 PM is presented over here to cover the entire daytime. And taking the results of 10 AM as an example, here we can see that there are 2 images. And the first is the one which shows the simulation with unmodified building, and second shows the simulation with the green ball building morphology. And on the side there is a legend given over here. This shows the different color and the corresponding it shows the different colors and the corresponding temperatures. And we have the second, if we look at the first image, you can see that majority of areas is covered with red color, pink and mustard color, which belong to the higher temperature category. And after the use of green balls, we can see that in the second image, the majority of areas is covered with bluish shades, which fall under the lower temperature category. So here we can see that there is a definite reduction of temperature after the usage of green balls. So now let's see the results at 2 PM and 6 PM. Moving on to the simulated scenarios of different study area during the summer season, we can see that similarly the spatial variation of air temperature during the summer season is represented over here at 10 AM, 2 PM and 6 PM respectively. Here also the green balls have brought forth a considerable reduction in the air temperature. Then graphs showing observed simulated and simulated with green ball temperature in all the 4 different locations are given here. The blue denotes the observed temperature, the red denotes the simulated temperature, and the green denotes the simulated with green ball temperatures. And this is during the winter season. The next one is temperature variation at 4 locations during the summer season. From these graphs, we can gather that the observed and the simulated air temperature showed more or less similar trajectory and good correlation. And the slight differences that we can observe is actually due to the fact that we have used values closer to actual values in the input parameters. So if we have used the same actual values, then we would have gotten a better correlation. Now let's move on to the part that not to establish the correlation between these observed and simulated data, we use statistical techniques. Here we have used the techniques error matrix. Error matrix is used to quantitatively compare the performance of competing models. The error matrix that we have used here are mean absolute error, root mean squared error, and PEP stands for person error P, R square is the coefficient of determination, and MRE is the mean relative error. And if we take R square example, this gives the correlation. The theoretical ideal value for R square is 1 and the theoretical worst value for R square is 0. So if we observe that majority of the surfaces have their R square values goes to 1, which is the theoretical best value. So thus it is proved that there is a good correlation between the observed and simulated result. And we can see that the MAE values and RMSE values all follow the same trend. So after we see that the simulated results have similar correlation, good correlation, we can use the green balls to further reduce the temperature of the campus. Now moving on to the conclusion part, the ambient air temperature above the asphalt and concrete tile surface was remarkably high when compared with that of the shaded interlock tile surface. During both the summer and winter season, the surface temperature of the areas with urban construction material were also high when compared to the shaded region. We know that the NVMet simulation were carried out for 24 hours. The simulated results showed same trajectory and good correlation with the measured temperature reading. The error matrix showed a value close to their theoretical ideal values, which indicate that the simulations capture the variability in daytime temperature fairly well during both the seasons. The introduction of green balls have brought a considerable decrease in temperature. So here it is on an average about 1 to 2 degrees Celsius. So therefore, the introduction of green balls in urban planning can be adopted as an effective measure in mitigating the rise of air temperature due to the effect of construction materials. Here we have a list of publications. One of our papers were published in the UGC Chemist Journal, and another paper is communicated. Presentation in seminars or competitions are given below. A paper won the Best Paper Award in National Seminar conducted at St. Thomas College, Corangery, and there are a few other presentations in competitions or seminars. And here we come to the end of my presentation, and thank you, ma'am.
Yeah, it was really a wonderful presentation, Gianni Maria Matthews, and it is somewhat the need of the heart because we are just moving towards the pollution-free environment. But anyway, the conclusion which you concluded is known to everyone. That is, as you said, the green patched environment is decreasing the ambient temperature. And do you have got any other unique results apart from this year?
Ma'am, the aim of our project was to involve the EMISSION software. So, while we use the software, we have the provision to administer the different various techniques that we can use to decrease the temperature. To simply say that this can decrease, it does not have any scientific value. So, we are trying to say using a particular software that this has proved that it can be used to decrease the temperature. So that's kind of a scientific proof, and we are using statistical analysis for our to give a basis to our whatever things we have concluded.
Okay, whether you have designed the software or it is a copyrighted version?
No, ma'am, it's not designed. It is a basic version of EMISSION software that we have used.
Okay, dear. Anyway, go ahead. All this kind of future works or need of the hour. Thank you, dear.
Thank you, ma'am.
Thank you, dear.
Thank you so much.
Thank you, Gianni. That was a very good presentation, and it's a very unique idea to do a project on that. Okay, and I want a clarification about this green wall thing. What do you mean by that, and how will you implement that?
Ma'am, there are various types of green walls, commercially available green walls also, because in modern days, the scope of planning trees in urban areas with a large amount of population and building urban infrastructure density is growing. So green walls are basically we can administer plants, even plant onto the walls of building in urban areas. It can be even hydroponics, and those kind of things can be used in case of green walls. Maybe you're familiar with vertical gardening system.
Yes, that's what I'm expecting from you, vertical gardening. Yeah.
Even in Cochin Metro, we have tried it, but it's not completely done. But yes, but we have taken baby steps towards that.
A very good attempt. And I want to know one thing. Other than this NBMet, is there any other simulations or software that is available to know this microclimate change?
Earlier, what we used were like systems like a geographic information system, GIMP, and geovisualization, remote sensing techniques were used to find the temperature and all. But NVMet is a software where we can simulate and also we can administer various kinds of like for example school areas, or a variety of things can be done, and we can see to whether it is useful or not. So various techniques are used. Even NVMet also has gone through several versions itself. It also has several versions, different versions.
So what you're using is kind of a basic version.
Yes, we have used a basic version because to acquire the higher version it's really costly and also we basic version.
Thank you, Gianni, thank you.
So thank you, Gianni. That was a very good presentation. Now I invite Vaishna B. Number 2. Are you ready, Vaishna?
I'm ready. Yes, miss. I'm ready.
So now I invite Vaishna to present her presentation. PYPG 002.
Is it clear, ma'am?
Yeah, it's clear. It's clear, you can begin.
Hello?
It's clear, you can begin.
Okay, thank you. Okay, I am Vaishna, and now I am going to present my project Untitled Synthesis and Characterization of Phosphorus Doped Carbon Dot. Topics of my presentations are first introduction part and synthesis of phosphorus doped carbon dot, that exacts my aim of my work, characterization tools in the current work, result and discussion, and at last conclusion. So in introduction part we already know about nanoscience and nanotechnology. So these are the study and application of very tiny things. Based on the number of dimensions, the nanoparticles can be classified as 0 dimension, 1 dimension, 2 dimension, etc. So the 0 dimensional nanoparticles are often called as quantum dots. So here I am taking a typical quantum dots, that carbon quantum dots are generally small carbon nanoparticles. To make these kind of quantum dots carefully modulated by means of its fluorescence, their size and surface chemical groups, different chemical modulation techniques are used. But here I am taking doping of heteroatoms like nitrogen, boron, phosphorus. Any non-metallic elements can be used for doping purpose. Here in my work I am taking So this is a schematic representation of my work, synthesis of phosphorus doped carbon dot. So here we can see that the sugarcane juice is extracted from sugarcane, and it is a natural source that used. That why green synthesis. So many physical and chemical that are used for synthesizing nanoparticles, but they are not eco-friendly due to their production of toxic compounds. But in green synthesis, it is eco-friendly and low toxic, low cost, and also it is abundant in nature. That's why the importance of green synthesis is increasing day by day. Chemicals are a hazard of our nature. The carbon-based materials from various precursors that produced by hydrothermal carbonization. So stable, strong green or blue light emission carbon dots can be synthesized successfully by hydrothermal methods. So in the schematic representation, we can see that the pale green colored solution by hydrothermal treatment and continuous filtering and washing will be leads to a pale yellow colored carbon dot solution. So going to our first aim, synthesis of carbon dot. Sugarcane juice is carefully extracted from the sugarcane, which is filtered through Wattmann filter, and it is mixed with 7.5 ml of acetone, and it is heated 150 degrees Celsius 6 hours continually, and it is allowed to cool. Then the dichloromethane, a universal solvent, which is added to our solutions in order to remove the impurities, and at last the centrifugation process. At 6000 rpm for 20 minutes to remove the larger particles, and finally we get a clear light brown color solution of carbon dot is obtained. Next our aim is synthesis of phosphorus doped carbon dot. So the same manner, but the phosphorus precursor is added as red phosphorus. So the red phosphorus is mixed with the sugarcane juice and acetone. Then again it is continuous filtering and washing, and at last the centrifugation will be leads to the phosphorus doped carbon dot. So it is a different stages that shown in the figure. At last we get a pale brown colored carbon dot solution. Phosphorus doped carbon dot solution is obtained. So the characterization tools in the current work. So UV visible absorption spectroscopy, photoluminescence spectroscopy, and transmission electron microscope are the studies that are used to analyze the synthesis of phosphorus doped carbon dot. So the main part, result and discussion. UV visible spectroscopy. The UV visible spectroscopy is for CD and for PCD. So first we are analyzing for CD. In this graph, we can show the two peaks at 284 nanometer and 234 nanometer. So these different peaks will in the UV region. That means the substance that absorbing the UV light, and the highest highest absorption peak 284 nanometer. Next one is for PCD. So in PCD, here also the highest peak is at 283 nanometer, and there should be a shoulder peak around 230 nanometer. And for CD, the corresponding to 284 nanometer, they are attributing pi star transition in the carbon core and n pi star transition in the CO core. Similarly, for PCD, this 230 nanometer attributing n pi star transition in CO core, and the shoulder peak that attributing n pi star transition in CO core, and the highest emission peak at 283 nanometer that attributing the pi star transition in the carbon core. Next is chalk plot obtained from the absorption spectrum. So for PCD and for CD, linear from the graph that collecting to the x-axis, that will lead to the 4.09 band gap for CD and 4.02 electron volt band gap for PCD. Next is photoluminescence spectroscopy. So in photoluminescence spectroscopy, we varying our excitation wavelength from 330 nanometer to 400 nanometer. So from 330 up to 380 nanometer excitation wavelength, the peak, the wavelength is increasing. That is at 380 nanometer excitation wavelength, the highest peak is around 460 nanometer. That this 460 nanometer is lies on the blue region, that means the substance that emits blue light. Similarly, in the PCD, the excitation wavelength is varied from 340 to 400 nanometer. At 380 nanometer, 465 nanometer wavelength light is emitted. That is, it is also blue light. So, this is the figure for doped carbon dot solution under visible light and under UV excitation. So, both CD and PCD that exhibit maximum emission peaks in blue-green region. So, it is the International Commission on Illumination Color Chromaticity diagram that further confirmed the emission, confirmed the blue emission behavior of the carbon quantum dot. So for CD and PCD, the different coordinators are represented 0.1992 and 0.2404 for CD, and for PCD 0.1921, 0.2532 for PCD. Next our study is transmission electron microscope. This transmission electron microscope actually it is used for analyzing the morphological character of our substance. So here the nanoparticles are of spherical in shape and the size is 7 nanometers. In the SA pattern, that's revealing the amorphous nature of the synthesized dot. Because from this SAD pattern we get a bright spot at the center, so that bright spot revealing the amorphous nature of the synthesized dot. And at last our conclusion, the hydrothermal process has been successfully used to synthesizing doped and undoped carbon dots by using saccharum officinarum extract, and it is studied by UV visible absorption spectroscopy, photoluminescence spectroscopy, transmission electron microscopy, and it is further controlled by CIE color coordinates. So extensive research and development has been going on related to carbon dots due to the outstanding photoluminescence properties. Due to their low toxicity and biocompatibility, carbon dots are proving to be a great applications in the environmental and biomedical applications. Thank you for listening. Thank you all. Thank you so much.
Yeah, it was a very good presentation, dear. And Vaisha? Vaisha, am I audible, Vaishna? Hello. As you said, that is the phosphorus doped carbon dot are suitable for the biomedical applications. Whether do we have got any toxicity studies with this materials there?
Yes. Dots are harmful for us. Containing cell in culture.
There seems to be some network issue, dear.
And is clear?
Yeah, please continue.
Okay, ma'am. Actually, ready. Ma'am, is it audible, ma'am?
Yes, please.
Yeah. Yes, please. Yes, it's audible.
Okay. Ma'am, cadmium selenide is a type of quantum dot, like traditional semiconductor quantum dots. So these type of quantum dots kills cells in culture. So these are harmful. Cadmium selenide type quantum dots are harmful. So actually it is used only for biomedical applications, not for treating patients like human, not treating for humans. Only for biomedical applications.
Okay.
They have the potential toxicity. Yes, ma'am.
Okay, ma. Okay, dear. And is there any unique reason to dope potassium explicitly with the carbon dot?
Potassium, actually, ma'am, phosphorus doped carbon dot actually.
Phosphorus.
No, ma'am. So many research is based on nitrogen doped carbon dot. So when I took so many studies, the phosphorus doped carbon dot is rare, and I think red phosphorus is comparatively harmless. So that's why I am taking red phosphorus.
Okay. Thank you. Good work, dear. Continue this work. Thank you.
Thank you, ma'am. Thank you.
Over to Amy, Mama. Over to Amy.
Okay.
Vaishnav, that was a very good presentation. And I just need one clarification. What is the reason behind using sugarcane extract in your synthesis, green synthesis? Is there any specific reason why you chose sugarcane?
Actually, no, not like any reason for that. Actually, I am aimed to invest in green synthesis. That's why any juices like apple juice or like any natural juices can be taken. But there is no typical reason for taking sugarcane juice.
So then, what is the role of that sugarcane extract in your synthesis?
Sugarcane extract is a carbon precursor, ma'am.
That is your carbon precursor.
Yes, ma'am.
Okay. Yes, ma'am. Then, how did you, after synthesis, how did you confirm that you have got carbon dot? There should be some confirmation study, right?
Yes, ma'am. UV visible spectroscopy, like photoluminescence spectroscopy.
That is your confirmation study. Usually we opt for XRD is the first thing that we will do, right?
Actually, yes, ma'am. Yes. Actually, ma'am, we have a plan to. Hello, ma'am. Is it audible?
Yes. Yes, audible. Continue.
Okay, ma'am. Actually, okay. Ma'am, actually, we have a plan to taking the SPR characterization tool also, but due to this corona issues, we cannot do that. We can actually characterize the functional groups also.
Yes.
Functional groups of carbon dot and phosphorus carbon dot, but due to the corona issues, we can do that, ma'am.
Yeah, because you have to know your doping phosphorus too. So it's better to take EDAX too. To know how much percentage is present in your sample. Okay? Maybe after corona issue, you can do all the studies and publish the paper, I think.
Okay.
Make it as a
Okay,
thing.
miss. Yes, miss. We have a plan. Okay, miss. Yes, miss. We have a plan to complete our study also in application level.
Good. All the very best.
Okay, miss. Thank you. Thank you, miss. Thank you.
Thank you, Vaishna. You have presented
Thank
your
you, miss.
paper very well.
Thank you, miss.
So next I invite Shilpa Prince, number 6, PYPG006.
Hello.
To present her research work. Yeah. Yes, Shilpa. PYPG006.
Hello.
Yes, Shilpa, you can begin.
Good evening, everyone.
Presentation is, yeah.
I'm Shilpa Prince and my topic is flexible multi-wall carbon nanotubes, cobalt ferrite, PVDF, HFC carbide, promising candidates for EMI shielding. Aim of my project is to develop a flexible, lightweight and self-standing shielding material and to prepare multi-wall carbon nanotubes, cobalt ferrite nanoparticles loaded into PVDF HFC nanocomposite films by solvent casting method which can attenuate the undesirable electromagnetic radiation interference. So before moving on to a project, we need to be familiar with the term electromagnetic interference. What is electromagnetic interference? EMI is the phenomenon that occurs when an electromagnetic device is exposed to electromagnetic field. It is the interference caused by one electrical or electronic device to another by the electromagnetic field set up by its operation. Owing to drastic development, electromagnetic interference has become one form of pollution due to the harmful radiations, and the effects of electromagnetic interference include it may interrupt, obstruct or otherwise cause an appliance to underperform or even sustain damages. It may also cause electrostatic discharge or power disturbance. It also causes harmful impacts on human beings where the image is shown, thermographic image of the head with no exposure to harmful radiation, and after 15 minutes phone call, yellow and red areas indicates the thermographic heating effect. So this picture clearly implies how harmfully the electromagnetic radiation can affect human beings. There comes the importance of a shielding material. What does shielding material exactly do? Electromagnetic shielding is the practice of reducing electromagnetic field in space by blocking the field with barriers made of conducting or magnetic material. So the shield must be a conducting or a magnetic material, and here we are choosing PVDF as a metric polymer for an electromagnetic shield, which is design flexible, good pillar, specific interaction with pillars, and it is also electroactive responses to electricity, pyroelectricity and ferroelectricity. Its electric and magnetic dipoles can interact with the electromagnetic radiations and introduce a low system. Especially we are using PVDF HSP polymer, which is polyallyl difluoride for hexafluoropropylene. This is chemically inert, and addition of fillers do not cause any harm to the film. So PVDF alloy is not a good conductor, or it has poor electrical and magnetic properties. So in order to enhance the electrical and magnetic properties, we need to add certain fillers. Here, carbon nanotube is acting as a conducting filler, which has low density and large aspect ratio, and it disperses very well in an appropriate concentration in a polymer matrix. And by adding carbon nanotube, we can enhance the conducting filler, and the magnetic properties are enhanced by adding the magnetic filler cobalt ferrite. Addition of metals and metal oxides increases magnetic permeability and total energy. Cobalt ferrite is chosen because it has high coercivity, modest magnetization, high electrical resistance, and high anisotropy constant. It also has inverse spinel structure and high Curie temperature. Moving on to the synthesis part. Synthesis of cobalt ferrite was Soil method. Initially, 1.2 molarity of citric acid was added to 100 ml of distilled water and stirred well. Then 0.4 molarity of cobalt nitrate was added and stirred well. Again, 0.8 molarity of ferric nitrate was added and dissolved. After that, the solution was stirred well until the solution acquires a gel format. This gel was burnt in a blast furnace at 500 degrees Celsius, and thus we obtain the cobalt ferrite nanoparticles. Images of the synthesis is shown here. After that, we need to prepare multi-wall carbon nanotube and cobalt ferrite loaded PVDF HSP film. For that, we chose solvent casting method, and here 1.5 gram acetone and DMF was taken in equal proportion, into which 1.5 gram of PVDF was added and stirred well using a magnetic stirrer at a temperature of 60 degrees Celsius. Then 10 weight percentage of polymer, that is 0.15 gram of CND was added and allowed to disperse. Then cobalt ferrite was added in different weight percentage, which was 2.5 weight percent, 5, 7.5 and 10 weight percentage of cobalt ferrite. We changed the concentration of cobalt ferrite in order to study the dependence of these cobalt ferrite magnetic fillers on shielding efficiency, and this was the required film we obtained. Moving on to the characterization technique, it involves X-ray diffraction, transmission electron microscope, atomic force microscope, scanning electron microscope, LCR, series laser, and EMI shielding device. X-ray diffraction pattern, the sharp peaks indicate that CFO particles is crystalline in nature. Comparing with JCPD's latest cubic spinel structure of the CFO nanoparticles was identified, and size of the particle using stereo equation we found it was 27 nanometer. Then TEM analysis, from TEM images it is clear that CFO nanoparticles have spherical morphology and particles with aggregation behavior because of its magnetic nature. Average size of the particle was 31 nanometer, which was in agreement with the particle size study. And the figure D, SAED pattern shows that CFO is polycrystalline in nature. Then FESM analysis of neat PVDF. We prepared a neat PVDF film and cobalt ferrite and carbon nanotube loaded PVDF film. The FESM analysis of both the films shows that the particles were well distributed in the polymer matrix, and the AFM analysis is used to find the surface roughness, and here you can see that on increasing the filler concentration, surface roughness was increasing, and it may cause brittleness. But here surface roughness is not too high to become brittle. It is around 11 nanometer, 24 nanometer and 35 nanometer respectively, and hence since the film is not brittle, it is flexible and can be used for electronic applications. A material with high AC conductivity and dielectric loss values would show electromagnetic shielding effectiveness. So we need to study the electrical property, and for that frequency dependent dielectric studies of the nanocomposite film is shown here. Here we can see that dielectric constant decreases with increasing filler concentration, and low frequency regime dielectric constant is very high, and high frequency regime dielectric constant is very low. This is because electrical dipole within the nanocomposite film is in phase with the radiation of applied AC electric field strength. At high frequency, electric dipoles lag behind the frequency of applied electric field. Then the frequency dependent dielectric loss of the nanocomposite film shows that addition of filler improves the dielectric flows. We have already said that dielectric flows in order to achieve good shielding efficiency. So addition of filler is improving the dielectric flows, which is a required parameter for us. Next is frequently dependent AC conductivity of the nanocomposite. Here AC conductivity increases with increase in filler content. At low frequency regime, conductivity is too low, and at high frequency regime, conductivity is very high, where the AC conductivity dominates. Then the extent of attenuation of incident electromagnetic radiation are analyzed by measuring the scattering parameters, which is expressed in decibels. Here, EMI shielding effectiveness of the composite film is shown here, and from this figure it is clear that 7.5 weight percentage of CFO multi-wall carbon nanotube PVD film has shown a shielding efficiency of -24 decibels, and it has a thickness of 160 micrometers. This is because of the interaction of carbon nanotube and cobalt ferrite particles play a major role in attaining 99% of attenuation. It is also clear that on increasing the concentration of cobalt ferrite particle, shielding effectiveness is not increasing. So we can say that 7.5% is a threshold value, and it shows the maximum shielding efficiency of 99%. Moving on to the conclusion, cobalt ferrite particles are successfully prepared by Solving method, and XRD pattern shows that the particles are crystalline in nature, and STEM images shows us that the particles are spherical in shape, and the size of the particle is found to be 35 nanometer. FTSM images shows us that the polymer matrix without particles are well distributed in the polymer matrix without any aggregation, and the AFM images shows that the surface roughness is increasing with filler content, but it is not too much to become brittle. And electrical parameters like dielectric constant, dielectric loss, and AC conductivity is studied, and it is found that dielectric loss and AC conductivity increasing with increase in filler content. And electromagnetic shielding effectiveness of the prepared nanocomposite in X-band region was studied in order to evaluate the percentage of attenuation, and it was found that 7.58% of cobalt ferrite multi-wall carbon nanotube PVDF HSC nanocomposite film have a thickness of 160 micrometer and a shielding effectiveness of 24 decibels, 99% of attenuation. Hence, since this provides 99% of attenuation, we can use it in electronic devices such as terrestrial communication and aerospace communication. And the future studies include shielding effectiveness determined by the fraction method, accurate study of the prepared nanocomposite given by since the developed film process magnetoelectric study of the present composite can be carried out. Mechanical study of the prepared nanocomposite film can be performed to evaluate the flexibility. That's all. Thank you.
It was a wonderful presentation, dear, and was interesting. It's quite interesting also. And one thing, there is how much maximum efficiency that you could observe with all your films. You said that up to 24 decibels you have achieved. And is there any correlation with the size of the nanoparticle and the efficiency which you have achieved?
No, ma'am. Actually, there is a correlation with concentration of the particles. As we change the concentration of the particle, efficiency was changing, and we found that 7.5 weight percentage of cobalt ferrite was giving maximum.
Okay. So even if you increase the amount of the cobalt ferrite, and is there any appreciable change in efficiency?
No, actually it was decreasing. At 10% we observed around 18 decibels.
Yeah, why that kind of non-linear variation is there? Because actually cobalt ferrite, due to its very good magnetic property called ferromagnetism, it is going to act like a jammus. As you said, it is going to be used as an electromagnetic field, right? But according to the weight proportion, there is a non-linear variation. Why this flip in property? Actually, we are increasing the concentration from 1.5 to 0.5, and when you reach 7.5, you are getting the maximum shielding. And so likewise, when we go on increases, the shielding goes on, it should increase. But there is some flipped result is there. Why?
Maybe it may be a threshold value, so further increase had no changes in the shielding
Yeah, there comes the point called the nanostructure of your materials which you have used. That is the cobalt ferrite and CNT, which you have standardized with one particular sample, right? And after getting one sample, you are just measuring only, you are just varying only the weight percentage. So here comes the point that you have to tune up the structure of your nanoparticles, and so you can extend your efficiency apart from 24% or you can reach the maximum thing greater than 24. Okay, so here the matter is the confinement, quantum confinement of the nanostructure. So with the 36 nanometer or someone you are told, so with that size you are able to achieve only up to 24%. If you enhance the size, or if you just decrease the size of your nanostructures, maybe due to the quantum confinement effect, the effective might be doubled, or it might be 3 times greater than what you have achieved right now. But anyway, it is really a good work, and I hope this will help us to overcome the difficulty which we are facing it in the superconductivity related issues, right? When we have the superconductivity platforms, we can't use the e-gadgets. That is the main problem. So here, if we do have got this cobalt ferrite nanostructures, it will be used as an electromagnetic shielders. Yeah, really, it's a very good. And one thing, whether this could be used to avoid the disadvantages or the unwanted radiation on the cell phone or the mobile network plants.
Yes, of course, ma'am. That was a major advantage. And it's extended because the PVDF is piezoelectric in nature, so that its application can also be extended. It can generate electricity also. We can charge the phone without any external source by applying pressure.
Okay. Yeah, good. Thank you, dear. Good.
Thank you, dear.
Over to Jimmy Mama.
A very good presentation, ma'am. And can you tell me the difference between crystallite size and particle size? Your work is wonderful. You have done a very great job. But there was one mistake in your presentation. You have mentioned that in XRD result that you are getting a particle size of around 27 nanometer. Actually, from XRD you will be getting only the crystallite size. And particle size can be obtained from your TEM result. So there is a difference between your crystallite size and particle size. Your particles consist of 2 or more crystallites. Okay? So you have to correct that. That is the only thing that I found, and thank you so much. That was a wonderful presentation. A very good work.
Thank you, ma'am.
Thank you, Shilpa, for your beautiful presentation. And this comes to the end of the competition for the national level PG research project competition. Now we shall have the UG projects. Ma'am, do we need a break for 5 minutes, or shall we continue? There are 6 more students to present.
Will it be over within 15 to 20 minutes, sister?
We shall try.
Okay, sure.
Okay.
Just
Then I
ask the
think
participants to make their presentations shorter.
Shorter. Okay. Okay. Now I call number 1, Adul PT. Adul PT, are you present here?
Yes, ma'am.
Yeah. So kindly shorten your presentation.
Okay.
And you can begin.
Good evening, everyone. Present my final year project of my core project, that is home automation for physically disabled people. My name is Adul PT. My presentation number is PYU G001. The main objective of this project is to develop a home automation system which is remotely controlled by RF transmitter and receiver with a relay module. This is specially made for disabled people who can't control household devices. Present conventional wall switches located in different parts of the house makes it difficult for the user to go near them to operate. It is difficult for the elderly or physically handicapped people to use it. It is a single circuit using RF transmitter and receiver. It is very cheap by considering Arduino and Bluetooth controller remote system. RF transmitter sends signal to the receiver using special flexes which attach to the gloves. When the person holds the finger attached to the sensor, the light turns on, and again while doing the same, the light turns off. And when another finger be done like this, fan can be turned on and off. Here, the relay module at the receiver is a pushed on and to do the work. I'm briefly explaining about the circuit diagram and the working. So here the special flex switch plays a major role. The glove is made of a flex switch along with the length of each finger. The flex switch gives output in the form of voltage in high and low when the finger is bent. This flex switch output is given to the channels of the RF transmitter. And perform the operation. Further, the data is sent wirelessly to the receiver section. The gesture is recognized and the corresponding output is given. The block diagram and the circuit. The transmitter section and the receiver section. So the encoder the microcontroller is transmitted through the transmitter circuit board, and also it is received at the receiver section and decoded to the microcontroller. This is the main part of the circuit. Transmitter module. This is the receiver module. Here we can see that transmitter module we can switches that is this is a 4-channel transmitter module. So here only in this project I only use 2 channels, and other 2 are remaining freely because I only want to control the light and so this is the receiver circuit board. Here we can see the input data D0, D1, D2, D3, and this input is set to the inputs of the ULN 2003. This is the driver. It is each of these ICs to control the relay. Also it is used for controlling motors, etc. You can see when inputted the piece of the relay driver IC is directly taken at the corresponding output and turns the relay and places the output. So this is the ULN 2003 driver IC. It is famous relay driver integrated circuit. High voltage and high current integrated IC which use the Darlington array. And also a diode is used in diode and Darlington tester. The diode makes it visible with the inductive loads. These are the main applications of this relay driver IC ULN 2003. Also, I have designed a 5-volt regulator circuit for the receiver module because it is a stability phase 5-volt power supply. While saying about the RF module, it works on the basis of amplitude shifting. The type of modulation is ASK. So, about ASK and type of amplitude modulation which represents the binary data in the form of variations in the amplitude of the signal. Any modulated signal has a high frequency. Binary signals when ASK modulated uses 0 value for low input while it gives a carrier output or high input. These special PCBs are very cheaper, so I can make this circuit with a low cost. Also, we does not need any other program or any other to be done, because here you can see that if there is a learning button, so with the 3 modes, so we can control the by using this learning button. So no need of any other program And this is the gloves I have said because here we can see each finger is attached with the flux sensor. But actually, while considering about the flux sensor, it is very expensive. But I have made a flux sensor by using conductive sheets. You can see that while folding the fingers, the circuit.
Yes. Adul, you can conclude.
So I will show one video of my. May I show my video, ma'am? A short video of this project.
Over to you, ma'am.
I think you have seen this, so I am concluding. The home automation system has been experimentally proven to work satisfactorily by connecting sample appliances to and appliances are successfully controlled by the wireless RF module. The smart glove with a touch switch works well without any program. This is a low-cost home automation system was successfully designed and implemented and tested. Thank you. Thank you.
Thank you, Adul. It was a wonderful presentation. Not audible.
Ma'am, your voice is not audible, ma'am.
Is this audible now, sister?
Yes, ma'am. Yes, ma'am.
Yeah.
Okay. Do we need to ask questions for this project also, sister?
Your choice.
Yeah, actually it was a very good presentation. No need of questions, I think so. What Emima ma'am is thinking.
Okay, ma'am.
Ma'am, I don't have any questions, ma'am. It's a very good initiative, Atul. Keep doing. I just want to know what kind of appliances can be.
Anything which can be controlled by using a switch.
Anything which can be controlled?
Like home appliances like a fan, bulb, AC, washing machine, anything which can be controlled by using a switch.
Okay. Can it be like linked to your mobile phone so that in case of emergencies you can call someone, a voice activate?
There are many processes, but I do this because I want to make something which is very cheap.
Okay, yeah, good.
While considering other Arduino Bluetooth modules that are very expensive.
Good. Good initiative, Atul.
Okay, thank you, Adul. So now I invite number 2, Anis Fatima, to present her work. Anis Fatima, are you there?
Yes, ma'am, I'm here.
Yes.
Good evening to one and all.
You can shorten your
Yes,
presentation.
ma'am, sure.
Quick.
Good evening to one and all, and for the dignitaries who are on the screen, and all to my dear friends who are gathered in that meet. So once again, good evening to all. My name is Anis, and my project presentation is about holographic aspect of panoramic universe. Is my screen? Ma'am, is my screen visible to everyone?
Yeah, it's visible.
Okay,
Yes,
ma'am.
it's visible.
Sure.
You can continue.
So, holographic aspect of panoramic universe. The title itself says that the panoramic universe, that the universe is endless and keeps on expanding with regards to totality of existence. So, I had focused this project in a theoretical manner where it explains about the holographic aspect of the panoramic universe. So, first, seemingly 3D space-time is encoded by limited amounts of 2D information. That is, for example, the apparent 3D object can be limited in 2D information. Like, for example, we are viewing a live video which is in a 3-dimensional video in a 2D screen. So where this idea that the universe might be a hologram come from? That is exactly from the black hole information loss problem. We know that black holes are apparently 2D and never, for example, light passing through the black hole even doesn't escape from that, because the event horizon grabs the objects which has mass into it. So that is what is exactly called black hole information loss problem. So the 2D surface of a black hole gives enough information to completely distract any seemingly 3D objects inside it. So the 3D object, when compressed, transforms to 2D object, as well as vice versa. A 2-dimensional object which when projected transforms into a 3-dimensional object. So ultimately on compression, an object becomes -1 dimension, and on projection an object becomes +1 dimension. So then moving over to hologram. Since what is meant by hologram then? A hologram is the physical recording of interference pattern which uses diffraction to reproduce 3-dimensional light field, resulting in an image which retains the depth, parallax and other properties of the original scene. So holography is the science and practice of making hologram. So the science of making hologram is ultimately known as holograph. So hologram, if you can see the picture, related to the observer, when the hologram is being that is the holographic image which is to be projected is being projected on by a 2D image on the 4 sides. Ultimately it forms a virtual image of 3D. So this 3D illusion is called as hologram. So then I have made an this in experimental procedure, as the ratio of the hologram, the ratio to obtain a clear hologram is generally 1:6. That is 1 centimeter is to 6 centimeter, and the sideways is 4.5. So that it produces an angle of 45 degree, which you can see in this before projection. That is before slide. That is 45 degree, so that you will get a clear 3D image. So then moving over to it, when you stick on 4 sides, you will get ultimately a hologram of this exact size. And then that is the handmade hologram. So how does it work? So the 4 symmetrical optical that is opposite variation of the same image are projected onto the 4 faces of the pyramid. By this principle, each side projects the image falling on it to the center of the pyramid. This projection works in unison to form a whole figure, which creates a 3D illusion. So this is what is called as hologram. So how could we prove that the universe is an hologram, since it's just as you can think, it's just an illusionary one? Then how could it be a real one? But as far considered, Macedonia, the scientist demonstrated that the hypothetical universe could be a hologram, because he emphasized the concept of the de Sitter space and anti-de Sitter space. That is, with increasing time, for example, if you take a cloth, it will be apparently visible to you as 2D, but if you focus on it, the threads and it has some depth. So ultimately another dimension adds up to it, that is in the form of height. If you project it, you can see the thread and everything so clearly. So this is what is called as anti-de Sitter space or the de Sitter space of a cloth. In simple words, I'm explaining to you. That's it. So then moving on to the next slide, this is then it's further proved. Fermilab's holometer further proved the concept of this holographic universe, where the Fermilab's holometer tells you that the basic, that is the amount of information present is limited in the space-time itself, because if you see on the that is for example, if you take on the videos projected by Netflix and everything, the amount of that is the information is being compressed, and it is projected into in a more clear way. So in this way, the complex informations can be stored in a compact manner. So if this is possible, then the universe, which could be a hologram, is also possible. So then the Euclidean theory, this is the wonderful evidence that I want to tell you, because the Euclidean theory, we all know that the sum of the internal angles of a triangle adds up to exactly 180 degrees. So that if you focus on the positively inflated, that is positively outside inflated triangle, the angle, that is omega naught, is greater than unity. Whereas in a negatively inflated triangle, that is inside inflated triangle, the angle omega naught is less than unity, that is less than 180 degree in the sense. And then only for the flat universe, the parallel lines never intersect, and the unity is the law of unity obeys exactly over here. So the Euclidean geometry wants that the universe is ultimately flat and keeps on expanding. So then, as far we can conclude that there is no edge to the universe, and space spreads out infinitely in all directions. Furthermore, galaxies fill all the space throughout the entire universe. So the only way for the universe to be flat and uniform literally everywhere is for the universe to be infinite and has no edge. So I conclude that it is my research project where I had concluded that we live in a flat universe, which is a hologram, no doubt. So the three-dimensional object can be stored in a two-dimensional surface. So thus an object on a cosmic scale on a dimensional aspect is equal to the apparent dimension is equal to actual dimension plus or minus one dimension. That too, the special cases where the plus one dimension, when the object is smaller than the observer, that is related to the observer. If the object is smaller, then it is plus one dimension. And then minus one dimension when the object is larger than the observer, that is related to the observer. So thank you. Thank you, ma'am. Thank you, everyone.
Thank you, Anis, for your wonderful presentation about your work.
Thank you so much, ma'am.
Yeah, Anis, it was a very good presentation, and I hope we would have made this at a very low cost plan, right?
Yes, ma'am. Yes, ma'am.
Yeah. Anyway, and you can just improve this to a standardized model, and which could be used in the laboratory too.
Okay, ma'am. Actually, the complex holometer is the laboratory work, and this is my theoretical project where the scientists are doing experiments on how the universe is. So the need of the hour is whether it is a flat universe or Big Bang theory. The evolution is being that is the research in this area is going on, and I strongly emphasize that our universe is totally flat. So this strongly emphasizes the concept of flat universe.
Wow, very good, very great.
Thank you so much.
Very good.
Thank you so much, ma'am.
So now I invite number 3, Parvati, to present your work.
A very good presentation, Annie.
Thank you, ma'am. Thank you so much, ma'am.
Can I ask question or not? Sister, can I continue?
Yeah. Yes.
Anis, I have one question. Is there any theoretical evidence that the universe is a hologram?
Yes, ma'am.
Anis, are you there?
Yes, ma'am. I'm here, ma'am.
Can you tell me a theoretical evidence suggesting that the universe is a hologram?
Yes, ma'am. Actually, the Fermilab's holometer that I said, that the space-time is limited, and that is the space-time itself is limited. It proves that the complex dimensional aspects can be compacted in a simple dimensions. So it proves that the universe is totally a hologram. The scientists called Hogan and Susskind in 1857 described the concept of holographic universe, ma'am.
Okay. Actually, you can also know that by cosmic microwave background, by studying the cosmic microwave background. That is also another theory. The University of Southampton, they have come up with a theory using cosmic microwave background to prove that our universe is not a hologram. Actually, it's a hologram. Sorry. Actually,
Okay, ma'am.
Thank you.
Sure, I will go through it, ma'am.
Thank you.
Thank you so much, ma'am.
Thank you so much, ma'am.
Okay, now I invite Parvati to present your work. PYUG 003.
Good evening everyone, I am Parvati and let me introduce our topic named Automatic Headlight Dimming and Anti-Colliding Technologies in Automobiles. Actually it's a combination of two systems. The first one is Automatic Headlight Dimming and the second one is Anti-Colliding. Why is this project? Actually the ultimate aim of our project is to reduce accidents due to high intensity beams and to avoid accidents due to obstacles. The graph shows that accidents increase year by year. So our ultimate aim of this project is to reduce accidents at due to high intensity beams and also due to obstacles. And robotics. Actually, the principle of our project focus on this robotics. It's a leading technology. It's a rapid growing field and researching, designing and building robots for domestic, commercial and military purposes. And it's also an interdisciplinary branch of engineering and science that includes mechanical engineering, electrical engineering, information engineering, computer science and others. The robotics involves design, constructions and operations of robots. And the backbone of robotics is that the programming. Our robot works in accordance with the program that it gives output corresponding to the program. And that is the computer system for the control, sensory, feedback and information processing. It's in short of our project is that whenever high intensity beam is comes from an opposite vehicles, it automatically turns into dim. And next one is that for anti-colliding systems, whenever there is a detection of an obstacles in the path of our vehicle, it automatically slows down and then stops. Then list of components. First one is Arduino UNO. Arduino UNO is the brain of our computer. That is, it's an open source electronic platform based on easy to use hardware and inputs, that is light on a sensor or a finger on a button or a triggering message, and also turns in a corresponding output such as activating a motor, turning on an LED, publishing something online, etc. Also, it's an input microcontroller that you can tell your board what to do by sending a set of information or instructions to the microcontroller or the board. Second one, light dependent resistance. That is LDR. It's a type of semiconductor devices and its conductivity changes in accordance with the change in the intensity of the light. LDR is the main device that used to use the system of automatic dimming. Then some ultrasonic sensor. That is ultrasonic sensor. It consists transmitter part and the receiver part. We all know that ultrasonic sensor emits ultrasounds of 40,000 kilohertz frequency. The transmitter part transmit the signal, and when it hit the obstacles and bounce back to the module, and the receiving signal is received by the receiver. And next comes the servo motor. Actually, it's an electronic device. Whenever you want to rotate an object at some specific angles or distances, servo motor can be used. Actually, it's made up of a single motor which runs through servo mechanism. If motor is used in DC power, then it is called the DC motor, or otherwise it is called the AC motor. Then DC motor, a class of rotatory electrical motors. Actually, a principle of DC motor is that it converts the direct current electrical energy into mechanical energy. Then comes light emitting diode. That is LED. It's a two-LED semiconductor PN junction diode, and it emits line when activated. That is, when suitable voltage is supplied to the leads, electrons are able to recombine with the electron holes within the devices and releasing energy in the form of photons. Then it's a block diagram of our project. There is a microcontroller Arduino UNO. Two LGs are connected to the Arduino. Their power supply is there. Here we use HC05 ultrasonic sensor. Then the two motors are there, which is connected to the motor driver. LEDs are used as headlights. Actually, the working of our project. As I mentioned earlier, it is work on the presetting programs that is stored in our Arduino UNO. Therefore, there is a threshold value for intensity and also for distances. If the intensity of a headlight is greater than the threshold value, greater than the threshold value, it's measured by LDR, and if it is greater than the threshold value, the highlight means automatically gets into dim. That is, the pre-planned Arduino dims the headlight, and the threshold value, when the intensity is less than that of the threshold value, it automatically backs to bright light. Then ultrasonic sensor. This distance between the obstacle and the vehicles is greater than the threshold value. Vehicles get slows down and stops. Distance calculation using ultrasonic sensor. There is ultrasonic, as I mentioned earlier, ultrasonic sensor have a transmitter part and the receiver part. And the transmitter part transmit the signal receiver, and we all know that the sound speed of sound in air is before the meter per second. And also by measuring the time required for this process, we can calculate the distance, and thereby we can locate the obstacles. Here it's a short working video of our project. Whenever there comes a high intensity light, it automatically dims and sensing an obstacle. An advantage is actually automatically switches the headlight to low beam, and also it's avoid accidents. Not only avoiding accidents, but also it provides a safe and comfortable driving. An ultrasonic sensor is used in here. It's an inexpensive device. And some disadvantages of this project is that ultrasonic sensor has more difficulty in regarding the reflection from smooth, curved, thin and small objects. Therefore, it may not function properly under such circumstances. It works only at short range due to attenuation. That's all for my presentation. I hope you all enjoyed it. Thank you very much.
Parvati, it's a very good presentation. It's a need of an art actually here. It's always needed because we will not follow. Nobody will follow the rules properly. So it's a very good initiative. Thank you. Thank you.
So now I invite, thank you Parvati for your wonderful presentation. Now I invite Ian Banik, PG PYUG 004. Ian, are you there? Ian, number 4, UG project number 4. Okay, I call the next number. Anubama MC, PYUG 005. PYUG 005. Anubama MC.
Hello, ma'am.
Yes, you can present Anubama. You can present your PPT. Or shall I call the next person?
Ma'am, can you please wait?
Okay. So I call out the next person. Ridul Shaji, PYUG 006. Yes, Ridul. Yes. Ridul, you can present your PPT.
Okay, is it visible, ma'am?
Yeah,
Okay,
it's
the
visible.
title of my project is GSM based on appliance control. My name is Ridul Shaji and the participation number is PYUG006. What is the objective? The system aims to remotely control devices using mobile phone. User can control device just by sending commands to SMS. The system also provides acknowledgements by means of SMS. These are the main components: Arduino Uno, GSM controller, and the relay module. This is the Arduino. Arduino is the heart of the system. It is a microcontroller. Arduino is a
Arduino is the heart of the system. It is a microcontroller.
Arduino is 320 and developed by Arduino CC. These are the specification.
And developed by
5 volt and input voltage is 12 volt and having a flash memory of 32 kilobyte and 1 kilobyte of flash memory
and 1
kilobyte
of electrically erasable program.
and the 14 IO pins of the Arduino are individually controlled.
And the 14 IO pins of the Arduino are
and 0 and 1 are RX and DX. RX is the receiver, DX is the transmitter. These are the serial communication pins of the Arduino. It is also inbuilt reset button, which is LED connected to digital pin 30. Also there is a resetable fuse for our connected to digital pin 30. Programming of the Arduino can be done through Arduino software, which is readily available in the net. The Arduino Uno comes with a pre-bound bootloader, so we can directly connect it to our smartphone and directly upload the program. This is the GSM module. It is a miniature GSM module works in module. We can use this module to accomplish almost SMS text messages, make or receive phone calls connecting to internet through GPRS and more. And operating voltage is 3.4 to 5 volt. There is also inbuilt LED for network status indication. The LED blinks in every 3 seconds. It shows that data connection is established with the cellular network provider and GSM module. So it is cellular for send or receive voice and SMS. An antenna is needed for our communication and use helical antenna. Netwin is the pin where we solder the antenna. This is the positive and RX is the receiver, TX is the transmitter, GND is the common ground pin. This is the relay module that we use. The relay module is an electrically operated switch that allows user to turn on or off a circuit using voltage current much higher than a microcontroller. These are the specification. It has long life module with diode current protection, short response time. It has long life module with diode current protection, short photoelectric isolating DC. These are the pin configuration. IN1 and IN2 are the individual controllable pins of the relay 1 and 2.
IN1 and IN2 are the individual controllable pins of the
This is
relay
the
1 and 2.
connection diagram of my project. How the system works. The system works in the following manner. The SMS sent by the user is received by the GSM receiver and then sent to the Arduino microcontroller. The microcontroller then activates appropriate relay for the appliance and control it. Once the device is activated, an appropriate relay for the appliance and control to the user. What are the commands that we used for the operating the system? Hash A star is for turning on the first relay, hash B star is for turning on the second relay, and hash 1 star is for turning on the first relay, and hash 2 star is for turning on the second relay. These are the pros and cons of the system. It is fast, reliable, cheap. The making cost is just below 500 rupees, and since we use a SIM card in the GSM module, we can access it anywhere from the world. It uses simple circuitry, can control AC as well as DC devices, provides acknowledgement in the means of SMS. The number of relays can be increased according to the need. And the clone we need to recharge SIM card used in the GSM module. And these are the area of application. The devices has large area of application. Example is home appliances, agriculture feed, industries, farms, colleges, etc. Also, I have a video regarding the working of my project. So,
on the video.
यस सर लेकिन मैं तो एक असिस्टेंट प्रोफेसर हूँ और मेरी जिज्ञासा इतनी बढ़ गई है जो है एमडीपी को सुनकर और पार्टिसिपेट करके और मैं भविष्य के अंदर जो है वो नेट से रिलेटेड काम करना चाहता हूँ। मेरा एक प्रश्न है
This is our system. We need to encapsulate all the components into this our system. We need to encapsulate all the components into Arduino microcontroller. And these are the Arduino microcontroller. Also, we have Arduino module. This is complete GSM module. This is complete GSM module. This is where we need to insert the SIM card. This is where we need to insert the solder card silicon panel. We need to connect all these components as per the connection diagram. We need to connect all these components as per the connection diagram, detailed connection diagram of our system. This is the detailed connect all the components as per the connection diagram. I have connected all the components as per the connection diagram, one output. Now I will connect this bulb is into on or off output. So Mr. Viren, can it on or off with my system connecting to the mobile phone. Connecting it. Connecting it into the master lens output. Connecting it into the master lens output. So the connection is made. Now I am going to turn on the system. So the connection is made. Now I am going to turn on the system with no powered on. Okay, you can see the system is now powered on. GSM module. You can see there is a LED GSM module. Okay, now the LED is blinking in every 3 seconds. That means the system is now in a stable condition. It is ready for use. System is now in a stable condition. It is ready for use. Also, the system will send a message into our mobile phone. I will show you. The system will send a message into our mobile phone. This system is you. Both the relays are off, and this is the message. This is the both message that are sent by the system. This is the message that is sent by the. For adding on the first relay, we need to send a command. For adding on the first relay, we need to send a command. The message hash #, and it's going to send the message hash #. This message will turn on the one relay and associated bulb. This message will turn on the one relay and now the bulb is turned on. Also, we will get a message from the system on. Here is the message relay 1 comes on. For turning off, here is the message of the relay 1 on the bulb. We need to send as 1 step. The relay on the bulb, we need to send as 1 star to the system as 1 star to the system. Okay, now the bulb is turned off. Also, you will get a message of the system turned off. And here also, let's get a message of the system. This is how the system works. And hash, this is how the system works. And hash P star is for turning on the second relay, but there is no turning for it. There is second relay, but there is no second relay output. Sorry, so there will be nothing, but the system will provide output. So then say this nothing, but the system will provide. Instead of this bulb, we can use electronic equipment such as microwave oven, washing, electronic etc. For the microwave oven, this use bulb etc. For the system, I have this reliable, fast, and comfortable performance and reliable, fast, and often an advantage that we can control things from long and advantage that we can control it from the long distance. Thank you. Bye.
So that's the end of my presentation. Thank you for your time.
So that's the end of my presentation. Thank you for your time.
Thank you, Ridul, for your wonderful presentation.
Thank you, ma'am.
Okay, thank you, ma'am.
No questions, ma'am. I just
Ma'am,
want to
do you have any
congratulate Ridul.
questions?
That was a wonderful initiative, Ridul. Ma'am, I just want to congratulate Ridul. That was a wonderful initiative, Ridul.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Thank you so much.
So now I call the next number PYUG005 Anubama MC to present her work. Anubama MC PYUG005 to present your project work. Yes, you can make it full screen. Anupama, you can begin.
Hello, hello. And can you see? Hello, hello.
Ah, yes, yes.
And can you see?
Yeah. The screen is visible. Only thing you have to make it full screen. Slideshow, full screen. Click on slideshow. You just click on slideshow. On the top menu bar. Menu bar, slideshow.
Menu bar, slideshow.
You go to you go to slideshow from the beginning. Click from the beginning. First one, first icon. Yes. Yes. Now we can begin.
Good evening. Here we gonna be introducing our RFID based attendance system. RFID based attendance system is a new concept we are introducing to you all. As we all know, in most education institutions, administrators are concerned about students' irregular attendance. For that, we are introducing it. It can be used to track attendance for students in schools, colleges, and also in working places. This is usually consists of an RFID reader and a chart. It is also wireless communication, and it is very useful because it can uniquely identify a person or a product based on a tag incorporated. It can be quickly done and it takes less than a second. Move on to principle. RFID based attendance system consists of an RFID reader and a tag, LCD display and a microcontroller unit. It reads the card, and from there it is connected to the microcontroller. So, and the reader then transfers data to the microcontroller, and if the tag is indicated, microcontroller takes the attendance. If the tag is indicated, we go on to the component list. We have Arduino, LCD, RFID, buzzer, RTC, power. In Arduino LCD, in the sense it is a liquid crystal display. As we have to for that we have to display the attendance of the student. Buzzer is an alarm. Then RTC is the real time clock. As we have to give the time of the student. And power supply. Here we are power supply is given us SP taking it as laptop. So, okay. The aim of the project is to design an RFID-based technology-based attendance system using microcontroller in which the attendance of the student or employees are automatically recorded with the swipe of the card. Here, when the circuit is powered on, initially the microcontroller will display the message as swipe the card on the LCD display. And when the RFID reader dictates the ID card, it will send the unique card on the microcontroller via serial terminal. This is the circuit diagram of the Arduino RFID attendance system. So it has many advantages. So first one is it is of course a loss code solution. And then with a little software modification extensible to any other microcontroller, such it can using our facilities we can using our limitation we can use many other microcontrollers as it. Move on to disadvantages. This has only one disadvantage, that is since there is no other identification mechanism. If someone picks up some working part, then he gets the full access. Applications. RFID based attendance system can be used in education institutions, industries, anywhere. Then emerging technology as used in applications where authentication is needed. Limitations of based attendance system in the sense, but RFID based attendance system but there's the chance of misuse and one person can give another person attendance if he or she is RFID card take. If the card was swiped for more than once, there is a chance of giving attendance for the next days. Also, if the code is returned then going to future scope. Attendance system is an education system, workplaces, etc. Bank lockers, secured access, RFID based applications like a general framework to implement, storage places, cryptanalysis, a study of RFID techniques for better service and security, interfacing the system with GS so that the data can be transmitted through massive. So, briefly concluding by stating in a few sentences, the contribution of a solution to solving the specified problem, the latter the student-centeredness is a key concern in many schools, colleges, universities, etc. And also in working places, and students besides also enhancing this students monitoring system also gives accurate results and reduces paper-based works. Also provides mobility and automation in existing attendance processes. So that it will change our personal work lives and adorn and thank you.
A very good presentation, ma'am. No questions, sisters. You can proceed. No questions, sisters. You can proceed.
Okay, ma'am.
One presentation is left, I think. PYUG004. One presentation is left, I think. PYUG004.
Yeah, but he
Okay, then we can conclude, sister.
come, I think. He's not there.
Then we can conclude, sister.
Yeah. Okay. So this is the end of all the presentations of the PG and UG projects. Now I invite Dr. Bhagya to just say a few words. Dr. Bhagya, over to you.
Thank you, sister. Am I audible?
Yeah, you're audible.
Respected Dr. Ragam, Dr. Emima, dear teachers, my dear students. So first of all, let me congratulate and thank the Department of Physics, especially the coordinator, Dr. Sister Marley, Dr. Roslina, then Dr. Sister Binsi, Ms. Divya, for materializing this event a successful one. And I am very much, on behalf of the research committee members, I am very much thankful to Dr. Ragam and Dr. Emima for sparing their valuable time and giving the feedbacks also. So RECERCA 2020 was our first initiative and it was mainly focused to promote the research culture among the students. And in these presentations I could see the topics related to nanotechnology, electronics, radio frequency identification technology, Since I am a food scientist, food personal, I am not much aware about it, but definitely I am aware about the applications of this nanotechnology as well as radio frequency identification technology in food science. So actually I was happy to know the applications of these disciplines in physics. So I hope that these presentations, this might be benefited by all the students because now the traditional outlook regarding the research have been changed a lot. We have changed from the traditional research culture and now we are doing almost all types of interdisciplinary, multidisciplinary and transdisciplinary research. So the another thing I noticed was the presentations were highly organized and well presented and well explained by all the students. They have taken sincere efforts towards this presentation. So I was very happy and I think this was a good initiative from our part also. So hearty congratulations and best wishes to all the participants and hope this will be a memorable event in your academic life and you may continue the research in your higher education also. So thank you once again from the research committee. I express my sincere gratitude to all of you. Thank you.